In this video, we're going to look at everything you need to know for Cambridge AS Level Mathematics 9709, Pure Mathematics 1. In this video, we're focusing on binomial expansion. When working with binomial expansion, we work with brackets in the following format. Here, A is the first term, B is the second term, and N is the exponent of the bracket. Remember that if the terms are separated by a minus sign, then the B term is negative. It can be very time-consuming expanding a bracket with a high exponent, and adding like terms can lead to error. So there is a pattern that you can use. The number of terms in the expansion is n plus 1. So this is one more than the exponent n. For each term, start with a with an exponent of n and subtract 1 from n until the exponent becomes 0. For each term, start with b with an exponent of 0 and increase the exponent by 1 until it becomes n. We also need to multiply each term by a constant. The constants for the first and last terms are 1. The constants for the second and second last terms are n, the exponent for the bracket. For the middle terms, we use the constant of the previous term multiplied by the exponent of a and then divided by the position of that term. The constants follow a mirrored pattern. This means that the constants of the first and last terms, second and second last terms, third and third last terms, and so on, will all be the same. Then we multiply these values together to get a single term. These terms are our expansion. Let's look at some examples. Expand the following binomial. In this case, the bracket has an exponent of 3. 3 plus 1 gives us 4. So our expansion will have 4 terms. So let's write this as term 1, term 2, term 3, and term 4. We can start with our a value. For the first term, a will have an exponent of n, which is 3. So we say a to the 3. And then we decrease n by 1 for each term. So we get a squared, a with an exponent of 1, and a with an exponent of 0. Now we consider our b term. Start with b with an exponent of 0, then b with an exponent of 1. Add by 1, so we get b squared and b cubed. Now we need our constant. We multiply the first term by 1 and the last term by 1. We multiply the second term by n, which is 3, and the second last term by 3. Now we can multiply our values together. Anything with an exponent of 0 is 1. So now we have a cubed multiplied by 1, multiplied by 1 again. So this becomes a cubed. This is our first term. For our second term, we have 3 a squared b. Always write your variables in alphabetical order. Then we have 3. A with an exponent of 1 is simply a. B squared. Then we have 1 multiplied by 1 multiplied by b cubed. So our fourth term is b cubed. These are the 4 terms in our expansion. Let's do another example. Here we have the bracket of x plus 5 with an exponent of 4. N is 4, so we're going to have 5 terms. Let's say term 1, term 2, term 3, term 4, and term 5. Our a term is x, so we can start with x with an exponent of n, which is 4. Then we have x cubed, x squared, x with an exponent of 1, and x with an exponent of 0. Now we can consider our b term, which is 5. 5 with an exponent of 0, 5 with an exponent of 1, 5 with an exponent of 2, 5 with an exponent of 3, and 5 with an exponent of 4. Now we need our constant. For the first term, we multiply by 1, and for the last term, we multiply by 1. For the second term, multiply by n, which is 4, and for the second last term. For the constant of the third term, we need to look at the values we have for the second term. We take the constant, which is 4, multiply by the exponent of a, which is 3. 4 times 3 gives us 12. Divide by that term's position, which is 2. 12 divided by 2 gives us 6. This is the constant for the third term. Now we can multiply out. 5 with an exponent of 0 is 1. Multiplied by 1 is 1. Multiplied by x to the power of 4. So our first term is x with an exponent of 4. Now for our second term, 5 multiplied by 4 is 20. So we get 20 x cubed. 5 squared is 25. Multiplied by 6, we get 150. So this becomes 150 x squared. 5 cubed is 125. Multiplied by 4 gives us 500. So we get 500 x. X with an exponent of 0 is 1. So we have 1 multiplied by 1, which is 1, multiplied by 5 with an exponent of 4, which is 625. This is our constant. And now we have the 5 terms in the expansion. Let's do one more. Expand the following. Here our bracket has an exponent of 5, so we need 6 terms. So we can say term 1, term 2, term 3, term 4, term 5, and term 6. Our A term is 2a. The exponent will affect both the 2 and the a. So let's put this into a bracket. I have 2a with an exponent of 5, 2a with an exponent of 4, 2a with an exponent of 3, 2a with an exponent of 2, 2a with an exponent of 1, and 2a with an exponent of 0. My b term is negative 3b. So now I can say negative 3b with an exponent of 0, negative 3b with an exponent of 1, negative 3b with an exponent of 2, negative 3b with an exponent of 3, negative 3b with an exponent of 4, and finally negative 3b with an exponent of 5. Now I need my constants. We multiply the first term by 1 and the last term by 1. For the second term, we multiply by n, which in this case is 5, and the second last term as well. Now we need the constant for the third and fourth terms. So for the third term, let's look at the second term. I have 5 multiplied by 4, which gives me 20, divided by the position 2, which gives me 10. So multiply this by 10. And remember that the constants mirror the first and last term, second and second last term, and third last term, which means our fourth term is also multiplied by 10. Now in our first term, anything with an exponent of 0 is 1. So now we have 1 multiplied by 1 multiplied by our bracket. 2 with an exponent of 5 is 32. This becomes 32a with an exponent of 5. This is our first term. For our second term, let's tidy up our exponents. 2 with an exponent of 4 gives us 16. This becomes 16a with an exponent of 4 multiplied by negative 3b multiplied by 5. Now I can take my calculator. 16 multiplied by negative 3 multiplied by 5 is equal to negative 240. So I have negative 240, a with an exponent of 4, b. This is my second term. Now let's look at our third term. 2a cubed becomes 8a cubed. If you have a bracket with a negative and an exponent with an even number, 2, 4, 6, and so on, our answer becomes positive. So now I have 8a cubed multiplied by negative 3 squared, which is 9. So it becomes 9b squared multiplied by 10. Take my calculator. 8 multiplied by 9 multiplied by 10 is equal to 720. This becomes 720 a cubed b squared. Now let's look at our third term. I have 2a squared. This becomes 4a squared. Negative 3 cubed gives me negative 27. So this becomes negative 27b cubed multiplied by 10. Take my calculator. I'm going to say negative 27 multiplied by 4 multiplied by 10 gives me negative 1080. This becomes negative 1080 a squared b cubed. Let's do our fifth term. Anything with an exponent of 1 remains the same. So now we have 2a multiplied by negative 3 with an exponent of 4 gives me positive 81. It becomes 81b with an exponent of 4 multiplied by 5. Take my calculator. 2 multiplied by 81 multiplied by 5 is equal to 810. So I have 810 a b with an exponent of 4. Finally, for our last term, we have 2a with an exponent of 0. So this is 1 multiplied by 1. So all we need to look at is this bracket. Negative 3 with an exponent of 5 gives me negative 243 b with an exponent of 5. These are the 6 terms in our expansion. Next, I'd like to look at how we find specific terms in an expansion. To find specific terms, we can use the formula NCR multiplied by a with an exponent of n minus r multiplied by b with an exponent of r. Here, a is the first term, b is the second term, n is the exponent outside of the bracket, and r is the restriction. You can easily find a, b, and n from the given binomial, but r you will need to find. Remember that the exponent of the given term will help you find r. To find r, make the x term in the formula equal to the given term and solve for r. So let's look at an example. Find the coefficient of x to the 4 in the expansion of the bracket x plus 2 with an exponent of 6. Let's start with our formula. We have NCR multiplied by a with an exponent of n minus r multiplied by b with an exponent of r. From the bracket, we can see that A is x, B is 2, and N is 6. The question wants us to find the coefficient of x to the 4. So when we multiply all of these terms out, only our x term will have an exponent of 4. So to find r, we focus on the x term. In this case, a is our x term. So when we have a with an exponent of n minus r, we will get x to the 4. In the bracket, a is x. So I can say n is equal to n, which is 6, minus r is equal to x with an exponent of 4. When you have bases that are the same, x and x, your exponents are equal. So now 6 minus r is equal to 4, which means that 6 minus 4 is equal to r, which means in this case, our r value is 2. So up here, I'm going to say r is equal to 2, and now we can make some space. Now we can fill the values into the formula. N is 6, so this becomes 6c. R is 2, multiplied by a, which is x, with an exponent of 6 minus 2, which is 4, multiplied by 2, with an exponent of r, which is 2. Now you can take your calculator. We can say 6c2 is equal to 15. So this becomes 15 multiplied by x with an exponent of 4 multiplied by 4. 15 multiplied by 4 gives us 60. So we get 60x with an exponent of 4. So the coefficient is 60. Let's do another one. Find the coefficient of x cubed in the expansion of 2x plus 4 with an exponent of 8. Let's start with our formula. NCR multiplied by a with an exponent of n minus r multiplied by b with an exponent of r. N is the exponent of the bracket, so n is 8. A is the first term, a is 2x, and b is 4. The question asks us to find the coefficient of x cubed. And in the bracket, we can see that our a term is 2x. So in other words, we know that a with an exponent of n minus r is equal to x with an exponent of 3. Let's put in our values. We have 2x with an exponent of n, which is 8, minus r, is equal to x cubed. When you have an exponent outside of a bracket, it affects every variable inside. So in this case, 8 minus r affects 2, and it affects x. But to find the value of r, we only need to look at the x term. So I can write this as x with an exponent of 8 minus r is equal to x cubed. This means that 8 minus r is equal to 3, and we can see that 5 is equal to r. Let's make a note of this over here, that r is 5, and now I can make some space. Let's fill our values into the formula. I have 8c5 multiplied by 2x, let's put that into a bracket, with an exponent of 8 minus 5, which is 3, multiplied by 4 with an exponent of 5. Now I can take my calculator and I can say 8c5 is equal to 56. So I can say 56 multiplied by 2 cubed is 8. This becomes 8x cubed multiplied by, take my calculator, 4 with an exponent of 5 is equal to 1024. And now I can multiply these together. 1024 multiplied by 56 multiplied by 8 is equal to 458,752. 458,752 x cubed. This is the coefficient of x cubed. Let's do one more. Find the term independent of x in the expansion of 2x plus 3 cubed. When you are asked to find the term independent of x, we are looking for the constant. But we know that if we have a variable with an exponent of 0, it is 1. So in this case, we are looking for a term where x has an exponent of 0. So let's start with our formula. NCR multiplied by a with an exponent of n minus r multiplied by b with an exponent of r. From the bracket, we can see that n is 3, a is 2x, and b is 3. A is our x term. So we can say that x with an exponent of n minus r is going to be equal to x with an exponent of 0. N is 3. So we're going to have n with an exponent of 3 minus r is equal to x with an exponent of 0, which means that 3 minus r is equal to 0, which means that 3 is equal to r. Let's make a note of this up here. And now I can make some space. Let's fill our values into the formula. I have 3c3 multiplied by a, which is 2x, with an exponent of 3 minus 3, which is 0, multiplied by 3 with an exponent of 3. When working with NCR, if your n and your r value are the same, NCR is equal to 1. So now we have 1 multiplied by the bracket with an exponent of 0, this is also 1, multiplied by 3 cubed, which is 27. So we can see that in this case, our constant is 27. Finally, I'd like to look at how we work with more than one bracket. Just like it's difficult to expand a bracket with a high exponent, it can be just as time-consuming to multiply an expansion by a second bracket. When working with two brackets, one will have an exponent outside of the bracket and one will not. Make sure that you know which bracket has an outside exponent and which one doesn't. If a bracket does not have an exponent outside of it, we cannot expand it. If on the odd chance both brackets have exponents, your exam question will ask you to expand them separately. When multiplying two brackets out, only multiply for the given terms. So what does this mean? We can multiply an expansion and add like terms, but this is time consuming. And in an exam, you only have a set amount of time to work with. Do not waste it on unnecessary things. To make this easier, I want to look at an example. Find the coefficients of x and x squared in the expansion of the bracket 4 minus x multiplied by the bracket 2 minus 4x with an exponent of 6. The second bracket has an exponent of 6 up here. So we know that we will have 7 terms with exponents of x ranging from 0, the constant, up to 6. But the first bracket does not have any exponents, so we cannot expand. This means that to find the x and x squared terms, all we need to do is multiply this bracket by the expansion of the second, but that is multiplying by 7 terms. To make it easier, let's look for the terms that we need. The first term in the first bracket is 4. So to get an x term, we need an x term for the second bracket. And to get an x squared term, we need to multiply this by an x squared term in the second bracket. The first bracket also contains an x term. To get an x term in our final expansion, we need to multiply by a constant in the second bracket. To get an x squared term, we need to multiply by the x term in the second bracket. From this, we can see that when we expand the second bracket, we only need the constant, the x term, and the x squared term. So let's expand this bracket for these three terms. To expand for a specific term, we're going to use the formula NCR multiplied by a with an exponent of n minus r multiplied by b with an exponent of r. In the second bracket, a is 2, b is negative 4, x, and n is 6. We need our r value. The second term is our x term, negative 4x. So we can see that b, the exponent of r, will give us our r value. Let's start with our constant. So we can say 4, the constant of c. For a constant, x has an exponent of 0. So b with an exponent of r gives us x with an exponent of 0. So r will be equal to 0. Now we can fill our values into the formula. N is 6, so this becomes 6c0 multiplied by a is 2, this becomes 2 with an exponent of 6 minus 0, which is 6, multiplied by negative 4x with an exponent of 0. When working with NCR, if r is 0, NCR will be 1. So now we have 1 multiplied by 2 with an exponent of 6, multiplied by the bracket with an exponent of 0, which is also 1. So now all we're working with is 2 with an exponent of 6. Take your calculator. 2 to the power of 6 is equal to 64. This is our constant. So over here, I'm going to make a note that our constant is 64. Now let's find our x term. So we can say 4x our x term, b, will have an exponent of 1. So if b to the r is equal to x with an exponent of 1, then in this case, r is equal to 1. So now we have NCR 6c1 multiplied by 2 with an exponent of 6 minus 1, which is 5, multiplied by negative 4x with an exponent of 1. When working with NCR, if you have an r value of 1, NCR is equal to n. So in this case, we have 6 multiplied by 2 with an exponent of 5 is 32, multiplied by negative 4x. Take your calculator. We have negative 4 multiplied by 6 multiplied by 32 is equal to negative 768. This is our x term. I'm going to write this up here, negative 768x. Now all we need is our square term. So I can say 4, the x squared term. In this expansion, when we looked for the constant, our r value was 0. When we looked for our x term, our r value was 1. So we can see that for the squared term, r will be equal to 2. So in our formula, I can now say 6c2 multiplied by 2 with an exponent of 6 minus 2, which is 4, multiplied by negative 4x squared. Let's take my calculator. For NCR, I can say 6c2 is equal to 15. So it becomes 15 multiplied by 2 to the 4 is 16 multiplied by negative 4 squared is also 16. So it's 16x squared. Let's multiply these together. 15 times 16 times 16 is equal to 3,840. Just make a note of this as well. 3,840 x squared. These are the only 3 terms in the expansion of the bracket that we need to consider. So let's make some space, and I'm going to write down the first bracket, 4 minus x. And for the second bracket, we're only going to use these 3 terms. 64 minus 768x plus 3,840 x squared. The question wants us to find the coefficients of x and x squared. So we only need to multiply out for x and x squared terms. 4 multiplied by 64 gives us a constant. That does not help us. We can't use it. 4 multiplied by negative 768x, that gives us an x term. So let's take a calculator. Negative 768 multiplied by 4 is equal to negative 3,072. So in my expansion, I now have negative 3,072x. 4 multiplied by the squared term gives me a squared answer. So now we can multiply 3,840 by 4 is equal to 15,360. Say plus 15,360 x squared. Now let's look at the x term. Negative x multiply the constant gives me my x term. So I get negative 64x. Negative x multiplied by an x term gives me an x squared term. And I get positive 768x squared. X multiplied by x squared gives me x cubed. I cannot use this because we are only looking for x and x squared terms. So these are the only values in the expansion that we need to consider. So now all we have to do is add like terms. Negative 3,072 minus 64 gives me negative 3,136x. This is my x term. Now for the square term, 15,360 plus 768 gives me positive 16,128 x squared.